Hello Internet, welcome back to our destructible 2D voxel terrain. In this video we are going to be looking into how to consolidate this a bit. So I was playing with this after I ended recording last time, after we kind of got the sphere or the circle insertion working. And I noticed a few things that I think we can improve. One, we've got like this big blob of yellow here. And the thing is I feel like we can consolidate this because there's a lot of bordering nodes. So we can actually bubble those up and actually just group those together and delete the lower level nodes. We don't need those anymore. So I think that's what we're going to be working on, is every node in a quad tree is a subdivision of 4 nodes is their children. That wasn't a good sentence at all. A node in a quad tree has 4 children and they're each next to one another. Also a bad sentence. What am I trying to say? Pretty much what I'm trying to say is, the idea is if all 4 of the children have the same value, then we can delete the 4 children and set that value to the parent. And since we're relying on that, our leaf nodes then can actually go back to that previous way we had them. So instead of checking depth, we can actually check if they have a leaf node or not. And that should allow this to work much better. Because after we have to just add on a little extra bit that says, was this set? And if it was, then we have to go through and remove it. So I think it'll be relatively straightforward, and it should, at least in the very least, it should significantly reduce the number of meshes or mesh nodes we have. I think we can get that going a lot better. Other than that, I don't really know what it's going to get us. We're going to have to find out. But it should allow us to get much more precision without having the same cost overhead. Or at least I think it will. So we're going to try it and see what happens. So let's get started. We have our quad tree component. Let's dive into our quad tree. And so what we're going to be working with here is this subdivide. So there's 3 things that it does. The first is it's going to see if it's at the end, if it's at the bottom of its depth. The next is it's going to create the nodes if they don't exist and kind of bubble all the way down. And then it's going to recursively subdivide each of those nodes. So what we need to do is actually insert our value here. We're actually going to be modifying our circle subdivide. We have 2 of them, if you remember, just because they're slightly different and we haven't consolidated them yet. So this one's the same. It's just a little bit different on the subdivision logic. So what we need to do is set the value down here. So if the depth is equal to 0, then we want this dot data equal to the value we wanted to set it to, and that will actually set our node, which means we can come up here and remove this, and we don't need that anymore. And we can't do that. So for the most part, I'm actually going to ignore this specific insert for now. We're not going to be working with it in this video. We're going to be strictly working with our circle subdivision, and then we'll bring it to the other one. I'll do that on my own time. It's going to be the exact same changes. It's just going to be a little bit, we will eventually need to bring those together. So we have this, and then we just return a linked list of those selected nodes. So to prove that this is working, we can drop our smiley face and start again. And so we should be able to draw just like we were, and we can. So now what we can do is, after this bit right here, what we want is this is going to recursively subdivide each of the nodes underneath it. And so what we want to do is, if We know it's not going to be the very deepest node. It's not going to be at the bottom of our tree because we've got this statement up here. So we know we're already at least one height above the bottom. So what we can do is create a variable. How do we want to do this? And we know there has to be subnodes because of the way we've set this up. Do we know there has to be subnodes? Yes, because we automatically create them. So we're going to take an initial value. We can do it like that, I guess. And we're going to set it to subnodes 0 dot data. And so this is going to be equal to the data at our first node. And then for, we're going to start at 1 because we already have the 0. And then from that to our subnodes dot length, we're going to iterate over each of those. And then if our initial value is equal to the subnode I data, then they're going to be equivalent. So this is important because it means if those are equivalent, it's got the same as our original node. And so if all of these evaluate to true, should reduce, we'll call it. So if it should reduce, then that's going to be, actually we're going to start that as true, and it becomes false if any value is not equal to the initial value. So if this initial value is not equal to our subnodes dot can't be applied to t-type, we'll fix that shortly. There's going to be something we'll have to implement. That's the word I want. Implement. So if that's true, then should replace, or should reduce rather, becomes false, and nothing will happen. And then at the very end, if we should reduce, then we want to set this dot data equal to the initial value, and we want to set our subnodes equal to null. And that should cause them to get garbage collected, so they'll just go away. Yeah. And that should be good. So theoretically, this should work. We just need to fix this because our current types do not allow comparisons, which I don't know how to fix entirely, but we're gonna figure it out. So how you restrict generic types is you do a where, the t type, and then you do like just how you would define a normal class. So where the t type extends object, we want system.object. Name can be simplified. I don't think this is valid, which is why it's yelling at me, I believe. How do we do this comparable? I think we can do it this way. So the initial value dot compare to, and we're going to compare it to this and say it's equal to 0, which would be, so if it's equal to 0, it's going to be equal. If it's 1, it's greater than, or if it's greater than 1, actually it's greater than, and if it, or greater than 0 rather. If it's less than 0, then it's less than. So we wanted not equal to, so it'd be not equal to 0. So if it's greater than or less than, it's not equal to, so we can do that. All of that is wrong because we need our t-type where t-type extends I comparable. And so that should work. A Boolean is going to be comparable. So I think that's good. Can we do struct? Does that actually work? Let me check this quick. So the difference between a struct and a class, I'm not going to get super into this, but a struct, okay, that doesn't work. But a struct is going to be slightly different than a class. You can do pretty much everything you can in a normal. You can do everything you would normally be able to do with a struct and a class. That they can both have functions. They can both have or whatever. How am I forgetting the name of a field? There we go, fields. They can both have fields. The difference between a struct and a class is that a class is going to be a reference type. So we're passing around these Quadtree nodes, and we're doing that, and we're returning them, and then we're modifying them, and things like that. If we were doing this with structs, that doesn't work. Structs are value types, which means if you pass a reference to, or if you pass one of them to a function, that's a totally different object now. So if you change it in that function, nobody else is going to see it. So structs are, there's a few other things that are different about structs. I'm not going to cover them because they're kind of tricky, and you should, if you care about that, read up on it because it gets down to the point of like how the compiler works and things, and at this point we're not going to dive into that. So there are differences, and one of the differences is value versus object or reference. Anyway, that was a tangent, but we have our iComparable now. The only other thing I want to do is do get leaf nodes, which is going to recursively grab our leaf, which is if the depth is equal to 0. So that is wrong, or not wrong necessarily, but it's not what we want anymore. We want if the nodes is equal to null. So it's a leaf node if it has no children. So that should work, and nothing else should have to change. That's the important part here. All of our other code already does this, or already works with this, because our generation stuff, ooh, doesn't like that. Doesn't seem to like that at all. I may have gone too far. So we've got our circle subdivide, we set our value, and then we return. We've got our subdivision. We've got our recursive call. And then after they've subdivided, we bubble up and then reduce. So the question is, why is this always reducing? Because that's apparently what's happening. I can put a breakpoint here and remove the other two. We don't need those. So then if I attach to Unity and try this again, initial value is false. That actually makes sense because I was, oh no, I was left clicking. Maybe that was the issue. Hold on. Did I just, oops. No, okay, that was not the issue. I have done something horrible. This sets the data. I'm gonna do one quick thing and print this off. We're gonna log out, reducing to, and then we're gonna reduce to our initial value. And so that should actually print out what we reduced to, or what value it was that we reduced. reducing to false. And there were a lot of them. And then I'm curious if we see any reducing to trues. And we do. So something else is broken in our logic. We can take this and say, it sounds like we're properly reducing, but something else is broken and causing everything to break. Which, I guess if it's broken, that makes sense. So, what's wrong? This was supposed to be simple. Alright, one thing I want to try quick, not sure it's going to make any difference, is I actually want to try setting that equal to 0 and then saying should reduce is and equal to that function. So this is just going to be, if you've seen the plus equals or whatever, same concept, we're just doing a bitwise and, which means if this statement is true, and then it will be true as long as this is already true, and then if this is false, it will set this to false. So it's just doing a and like that against it. So I don't think that's going to fix it. I'm just kind of curious. I honestly have no idea what this error is. I'm kind of confused. Like, reducing to true makes sense. So then why? I've got an idea. Let's do a conditional breakpoint. So conditional if should reduce is false. Well, actually, we don't need that. We can just do. Okay, we can do that. So when this is equal to false, then this is going to be true and will automatically break. So that will just be something we don't reduce, because maybe it's just constantly reducing, and that means our setter is broken, which would be weird. But maybe that's the case. So we're going to try it and see what happens. We'll start. Okay, so we do hit that. That's good. Shouldn't reduce there, so we don't. But then oh, I know what's going on. We're bubbling all the way back up to our like top level nodes, and those are all the same. So it's totally wiping everything out. I should have figured that out, and I'm sure there's at least one of you watching who's like, why didn't you think of this? So if you didn't follow that, when we subdivide, we create 4 nodes, and then we keep drilling down, and then we bubble back up. And so if we didn't flatten out everything and build it all the way back up, those top level nodes aren't going to have changed values, which means they're going to break everything. So we can fix this. And the way we're going to fix this is make it a nullable type. Right? Yes. Where t-type is nullable. That's what we want. And so we're actually going to make it nullable inside of our Quadtree node. We don't need to do it there. I don't know what I was thinking. And so we're going to change the default value. We had it as the default. Now we're going to do null. Doesn't seem to like that, so we're going to cheat a bit. So this is actually an implementation of the actual class. Must be non-nullable. Dang it. Okay. We're going to do this a little bit harder, I guess. That's hard. I don't... But we do... Okay, so what we do want is we do want some way to actually know that this is not a nullable type. So it actually will make sense to have this extend nullable. Cannot be used as constraints. It is... Oh. And you're not going to accept that, are you? Nope. Cool. And that's not going to work, is it? Nope. Cool. I have worked myself into a corner. What's the best way to fix this? Good question. I don't actually know. So what we want, I suppose I could do that, but it's not going to like that at all. And I don't really want to do that. We need some way to switch on this value. And so that's what we can do. It should reduce if this is true. So if it has initial value equal to, so if all of their initial values or all of their values are the same, then we want to reduce. But we also should reduce only if our subnodes are leaf nodes. So if they're not leaf nodes, then there's more data beneath them, and so we want to keep that. And that way we don't have to play with any of this crazy, what's it called? We don't have to play with any of the fun, like generic stuff, or nulls and special values and things like that. This should fix that. And it should prevent us from totally undoing everything we just did. Cool. So this should work now. I say as it doesn't work. I had such high hopes. Oh, whoa. Hold on. It kind of works. But it really doesn't like... Oh. Really doesn't like the bottom right corner of wherever it is. So I think we still have some bugs. But you can see it does work. And so you can see those blue lines are our subdivisions in our actual quad tree. And you can see we actually have like some bigger boxes here, which means far less polygons. We have 400 or 44,000 triangles, which each of those squares is actually 2 triangles. So that's actually not too bad. We just need to figure out what the heck is going on down there. Something is breaking it at the bottom. And I have no idea what would cause that. Okay, just to confirm my suspicions, I'm actually going to comment this out. And we're going to do that so that we can recompile all of this after breaking things. And that should... So we commented out our logic for reducing. And so just to prove that that's the error, we get this. And we're at like 3 times the number of triangles because we're doing this. But that's irrelevant. What we need to do is figure out what and that commented out code is breaking this. So it always seems to happen in the bottom right, which makes me think we're off by 1 or something. But I don't see any code here that would put us off by 1. I'm going to just quickly set this to 0. It shouldn't change anything. Actually, it will, because we have this isLeaf check now. So maybe that was the issue. So should be able to insert. Yeah, there we go. So everything's working perfectly now. We're at, not so perfectly. That's a little less nice. We seem to be getting some interesting artifacts. And it seems slower. Quite a bit slower, actually. Yeah, way slower. So I think our decision now is, do we stick with this and try to make it better? Obviously, it's reducing the number of the amount of geometry we have, but it's painfully slow. Our last version was significantly faster, but I'm guessing our slow bits are coming from that condensing algorithm. If we can make that faster, I think this whole thing will get significantly faster. And so the question becomes, can we get it faster? Maybe? Not sure. Oh, I've got it. So the reason that all of these sides are getting a little bit funky, when we started modifying things. So now that we've reduced our mesh here and made this better, what happens is when we go to put more stuff in there, all of that extra stuff reinitializes to the wrong value. So we can actually fix that really quickly. And we can do that here by setting our value equal to our current data. Instead of initializing it to the default value, we can inherit whatever value the parent node has. And so that way, when we reduce, it still breaks. This was supposed to work. It didn't though. Why didn't it? I'm genuinely confused about that. Because if we have a node and it becomes true, so we want to draw it, and then we subdivide it and give it that value, it should just go all the way down, right? And this is only happening when we are creating our subnodes, so that should be fine. Huh. Well, this whole thing is going poorly. I was thinking this would just be fantastic and work great and be super fast. And admittedly, it did reduce our triangles significantly. But this apparently is pretty slow. I don't know why. I mean, I can guess why. It's because we're doing, for every node, we do 4 checks, which isn't great. It's not even, frankly, good. But I was expecting better than this, and now it's broken. I mean, this is very wrong. We can do this. This will totally break it. It should just fill everything. Am I not saving? because I also would have expected that to do something else. Because we have our subnode, and we're creating a new Quadtree node, and then passing everything in is the constructor. Oh, found the issue. Oh, I am an idiot. Fixed it. I was correct. That should have broken it. But that was already broken. So now it's fixed. Initialize your values and actually use them when you pass them to your constructor. That's good advice. Everybody should do that. There we go. Now it actually is broken. Cool. That was just for testing, or proof of concept. I'll say that now, and then I'll forget to change it back. So this, we were currently setting it to the value. Don't want that. We want it to be the current data of the node. So it should, when we initially subdivide, everything is just going to be filled in back in with black or empty. But now, when we have these bigger nodes here, when we reinitialize those or resplit them, it should all fill back in. And so as we start building this out, it should start collapsing back in on itself. So I imagine this is going to be more efficient for smaller updates, just because it's going to burrow down, and then the problem is it scales poorly with very large updates, because for every node it touches, it needs to iterate over all 4 of its children a number of times, which isn't ideal, but for this, it's fairly quick because there's even less nodes. And as we slowly fill this out, we actually are reducing the geometry, or reducing-ish the geometry. So we've been sitting right around 20,000 triangles, which is, frankly, with modern hardware, that's nothing. And we're not really going up. If you do something weird, it goes up pretty quick. But then as you remove everything again, everything just starts disappearing again. So actually, I think this may be something we can actually use for our game, just because I don't think we're gonna be like blowing up a map entirely, at least not all in one go. And for these small updates, I think getting this reduced poly count is going to be significantly more advantageous. So, and it's cool. I like it. Which, it's a terrible reason to do any programmatic thing, because nobody's going to actually see it. But anyway, I don't know. I find it cool. So there's reducing a quad tree, I guess. I think it's cool. I already said that, but it is cool. So, few things. First off, this Sunday, I'm planning on doing a live stream. I don't know what it's going to be about yet, but I have this project that I'll explain more then, where we're going to make sort of an arcade game and do some interesting things with streaming. I won't say more because I don't entirely know how it's going to work yet, but I need ideas for a arcade multiplayer game. So if you have any, let me know in the comments, and maybe we'll make it. But we need something, and I don't know how much time I'll have either, or when it's going to be, or any of that. Not yet, at least. But the idea is we're going to try to make something simple and fun that can be played by multiple people on like a couch. And then we're going to do something really silly that I don't think anybody else has ever really tried. I mean, people have done it before, but not this way. So I think it'll be interesting. As for this, if there's any suggestions or feedback you guys have, let me know. I'm really curious what you guys think. These are kind of taking this off in its own direction and kind of exploring optimization and various algorithm design and things like that. If you guys want to just get straight to the like marching squares or something, we can do that. And we have on and off. Ooh, I killed Unity. Awesome. So that's new. But mostly we've just been exploring kind of optimizing this and making this more solid. So if you want to get to something that we can actually use in game, let me know. And we can certainly push towards that faster instead of tinkering with this. And this stuff can happen at any time. So the priorities aren't necessarily straight. I just think this stuff is really cool. So let me know. I'm curious what you guys think. If you've got feedback, I'd love to hear it. So yeah, until next time, see you, Jeanette.